Yeah, so my name is Adelbert Chang. I'm a lead data engineer at Target, though sometimes it feels more like I'm a distinguished YAML engineer, given the amount of YAML I have to write day to day. But today I'm really excited to be here to talk to you guys about Nelson, a deployment system I've been working with Tim Parrott, who's also in the front row, on for the past year or so. So let's get started. So earlier this year, I gave a talk of the same title, and I confess the same abstract at the Northeast Scala Symposium, as well as Scala Taiwan. In that original talk, I covered some things that I won't cover today. So if you've watched it before, there'll be new stuff today. And if you leave this talk wanting to learn more, there's that talk. And Tim Parrott also has a talk that he gave at a meetup last year. So that talk's going to cover stuff like traffic shifting, graph pruning, automatic shutdowns, and some more discussion on the implementation of Nelson, which is in Scala, which is why they're at Scala conferences. For this talk, we're going to cover more a system-wide view, as well as more focus on how users interact with Nelson, and then also how operators are going to deploy and maintain Nelson. Goals for this talk, I hope you guys can leave curious about Nelson, and maybe even if you don't want to use it at work, maybe you want to steal ideas from it or offer ideas for us to steal. So please talk to us afterwards. So those who know me or follow me on Twitter know that I've been kind of a functional programming nut for the past several years. I tweet constantly about it. It's been about 6 or 7 years now. And even as recent as last month, I gave an interview for this conference. And I talked about a bunch of different stuff, but even then the takeaway was apparently I still like functional programming. Which kind of begs the question, why am I talking about deployments, which is notoriously known as kind of a terrible place to be in, and also like on a reactive track, which when we do have like a separate functional programming track. So to answer that, I got into functional programming because I was looking for a way to program that would give me confidence and would sort of make me happy day to day. I could like write my program, leave for a couple of days, come back, and still know what was happening. And I didn't feel like I was getting that with sort of this mutable imperative code, and so that's when I got into functional programming and been sold on it ever since. But I noticed that as I hung around with like other programmers who were interested in like software methodologies and stuff, we would often build these really nice, pretty programs. We would construct them, strongly typed, well-tested, and all that good stuff. But when it came time to like build or distribute or deploy their programs, people had kind of different sentiments than they did for actually writing their code, right? So no matter what companies I've talked to or I've been at, tooling and infrastructure seems to be like kind of almost universally hated. And that was kind of weird to me, right? That we had a lot of catching up to do with tools. Our languages were great. We had a lot of advancements with languages. Brian Cantrell gave a great talk today about how Rust has changed the state of system software. But in terms of like tools and infrastructure, I think there's a lot of work to do there. So for me then, this was kind of the same problem that I had working with mutable imperative code, where I wanted to gain more confidence when it came time to, say, distribute and deploy my code. And I didn't always want to have to move in between like a yay programming phase, followed by like, oh no, I have to actually deploy this thing. So with some programming hubris, I was like, all right, is that going to play? No?
It's on the screen.
Oh, it's playing on the screen, yeah. So with some programming hubris, I was like, all right, next role I take, I'm going to do this myself. How hard can it be? Famous last words. So a couple of weeks ago, Yaron Minsky tweeted something. If you can't tell, I use Twitter a lot. But Yaron Minsky of Jane Street tweeted something that I thought was really interesting, which is that one of the most important perks you can give to your developers is a really good dev tools team. And especially having worked in this space for the past year, I've found that tooling and infrastructure have very profound but kind of hidden effects, where these are things that people are using day to day, and people sort of either get used to or get desensitized to sort of like the terribleness of these tools, but they have very large effects that I've seen. So like one of my favorite examples for this is for like running builds in CI or doing experiments, where if they're slow, for instance, or buggy, what often happens is developers are going to kick off a build or someone's going to kick off an experiment. They know it's going to take a while, usually like let's say 15, 20 minutes. They go do something else for a while, oftentimes much longer than it takes to actually run the build or do the experiment. They come back later, have to re-remember what they're doing, re-page into context, realize like the build broke or the experiment didn't go as planned. They kick it off again and they go do something else. I've seen that tons of times. And so the amount of wasted time on like bad tooling or buggy tooling isn't just the time it takes to make that build or run that experiment. It's like the time it takes for the person to come back and re-remember everything they were doing. Similar thing for deployments. If deployments are scary or unreliable, oftentimes I see like people become scared of deploying things. They deploy less frequently. When they deploy less frequently, the next time they actually go to deploy something, it's like a bunch of different changes. Things go down, they get scared. People start inserting like manual processes, and it's just like a vicious cycle. What I want to try to achieve are people who have sentiments like this, where people aren't so much scared of deployments or dreading deployments, but just sort of like, yeah, I'm going to deploy today, whatever. It's just part of my day-to-day. And especially when you get into like a continuous or like a really nice deployment cycle, it's nice to be able to say, like, I'm going to write this feature today, and then it's going to go out in like 20, 30 minutes. So that's the kind of state I want to achieve, and I think Nelson serves as an interesting data point to achieve that. So to start getting at that goal, I asked myself, why are people scared of deployments? And the answer I currently have is because deployments are often manual, they happen infrequently, and they have cascading effects. And to drill into that last point, by cascading effects, I mean a lot of the times deployments aren't going to be isolated, right? When you deploy something, it's not just like when you're developing code, you're just on your local machine, and you don't care about the outside world at that point in time, and nothing in the outside world is happening that's going to affect your development. But when you deploy, oftentimes it's being done in a way where everyone in the org or everyone across your microservices architecture or whatever is going to see your deployment, and if either you messed up your deployment or they didn't handle errors correctly, that can cause cascading failures or other cascading effects. And just to reiterate, oftentimes when things do have cascading effects and things go down, people get scared. They deploy less frequently. When they finally do have to deploy, they have big changes. They're going to insert like manual processes like, all right, let's all block out 3 hours of our time and walk through these changes or something like that. And then that just slows things down even more, and it's all terrible. So to address, so my theory is if we can address, if we can solve this cascading effects problem, we can at least make deployment slightly less terrible than a lot of people think it is. So the premise that I'm going to present and that Nelson more or less operates on is at the root of this cascading effects problem is mutability. Mutability, as always, to me, causes problems. So let's talk about that. What do I mean by mutability in the context of deployments? So here, pretend this is like a microservices graph. Each circle is going to be a microservice that does whatever, and then it's annotated with the version. And then the arrows are going to represent dependencies. So in this case, services B and E depend on service D for whatever functionality. Then the owners of service D want to upgrade from 2.1 to 2.2. And oftentimes what happens is they'll do a rolling update or something like that. And at the end, if everything goes well, the service D 2.2 is going to live in the same place of where 2.1 lived. This is an in-place deployment. Now, so this is what I meant by where deployments aren't isolated, where D has made a decision on their own to deploy something. B and E have to be ready for that deployment. Whether or not they're ready, they have to be prepared, right? And as is common, some people aren't going to be prepared for whatever reason, and things go down, right? Things go down, and this is because, again, everyone is sort of context switching all at once. And I attribute this to, one way I like to think about this is like similar to how we have problems with mutable data structures in concurrent environments. We have different teams maintaining their own service, they're operating concurrently, they're doing their own stuff, but they're all working on a mutable data structure, right, which is a service call graph, a service dependency graph. And when someone is mutating that data structure, everyone has to be ready, whether or not they like it. So how do we solve this problem given that lens? In a programming case, we're going to try to just, all right, let's try to limit the mutability. Let's try to make things as immutable as possible. So let's talk about what an immutable deployment model might look like. So same service call graph. Service team D wants to do an upgrade. But now this time, instead of doing an in-place upgrade, we're just going to deploy it somewhere else. But the key difference here being that the old version of D is still there, and services E and B are still pointing at the old version of D, right? So this is now more isolated than before. So this now begs the question, all right, how do services E and B and other dependents actually observe the change in D? So in the case of E, or even B, we'll get to that later. In the case of E, as an example, it's going to do pretty much the same thing as D. It's going to redeploy itself and make an explicit choice somehow, saying that I want to depend on service D 2.2 this time instead of 2.1. At this point again, the old version of E and the new version of E are coexisting. And for those familiar with like red-black deployment models, this is essentially the same thing, right? If the new deployment looks good, then we can shut down the old version and we roll forward. If the new deployment looks bad for whatever reason, you can shut down the new deployment and you still have the old one. Everything is OK there. Let's assume things are OK. We shut down the old version. We roll forward. At this point in time, the new version of E is depending on a new version of D. The old version of B is still depending on the old version of D, which is completely fine, right? Sort of the point of this exercise was that we weren't going to mutate the world for everybody. We were going to have people pick when they want to upgrade when they're ready. So let's say B is ready. B is going to redeploy itself, explicitly making a choice to depend on service D 2.2. And because B itself has a dependent, which is service A is going to redeploy itself and make an explicit choice to depend on a new version of B. And then again, at each point in time, there's a new version and an old version of the service. If the new one looks bad, you can shut down the new version and you're right where you were before. And if the new one looks good, then you can shut down the old version and roll forward. So in this case, let's say everything is good. A shuts down its old version. That frees up B to shut down its version, and then the old version of D can be cleaned up. And that's our final service call graph. So this way of managing services, for those familiar, is very similar to how persistent data structures work in programming languages. And just like how persistent data structures give us a nice vocabulary for talking about changing data, I think immutable deployments give us a really nice vocabulary for talking about service deployments. So how do we now actually implement this, right? It's easy for me to sort of stand up here and talk about, wouldn't it be nice if we had this model? But we have to actually implement this for this to be useful. So we can start by identifying that the core of this idea of immutable deployments is the idea of explicitly tracking version dependencies. So we have introduced a new problem with immutable deployments that wasn't existent in mutable deployments, which is because we can have multiple versions of the same service running at any time, and moreover, we can have even more than 2. We could have like 5 different versions of a service running at any given time. There's no longer like a single place that a service lives, right? Oftentimes you'll see like, we'll have d.prod.whatever.com. Now we have to talk about D at a specific version under a specific namespace or something. So we have to have some way of explicitly tracking where each version lives, as well as connecting different versions of a given service to different versions of, potentially different versions of the dependency. So one of the ways we can implement this is in the deployment system itself. Since every deployment has to flow through your deployment system anyways, it's in a good position to sort of track and publish information about what the state of the system is. Now, oftentimes, service discovery is going to be a separate notion from deployment, right? A lot of times, deployments are going to be like, here is a jar, or here's a Docker container, deploy it somewhere, and I'll figure out how to connect to my dependencies myself, usually in a mutable way. And so because of that, the call graph is invisible to the deployment system, so there's not much the deployment system can do. What we want is for the deployment system to be call graph aware, which basically means that every service that goes through our deployment system has to declare the name and version of itself and of all of its dependencies. And from there, the deployment system can then begin to build the graph, the internal graph of all the services and their dependencies, as well as begin to publish service discovery information, where if, say, E says, I want version 2.1 of D, the deployment system can first confirm that 2.1 of D exists in the system, and then also potentially give E or put service discovery information about D in a place where E can pull it down. Other stuff that it can do once the deployment system has full knowledge of the graph is also do things like traffic shifting, graph pruning, lifecycle management, stuff like that. So this emphasis on immutable deployments by reifying the service graph is the core of Nelson. And when I think of Nelson, I like to think of it as starting with the idea of immutable deployments and taking it to its logical conclusion. And everything else we build in Nelson in terms of tooling are sort of things to help make things more ergonomic now working with this new model, right? You get some stuff that sort of comes for free when you're immutable deployments, example being like you know where a given service lives. So we do lose some stuff, but we build everything Nelson has in terms of tooling, or because we're doing immutable deployments, we're going to do it right. So that was the conceptual basis of Nelson. Now I want to show how Nelson actually works from a users and operators perspective. So as I'm discussing those, keep in mind that Nelson is doing this immutable deployment model internally. So Nelson from a user's perspective first. Things are going to start with two files. So the first file is what we call a Nelson manifest file. It is YAML. I apologize. I'm part of the problem. So this is YAML file is going to be checked into the root of your repository. And it essentially details, very similar to how, like, if you're familiar with like a Travis YAML file or a build kite file or a Jenkins file, this is sort of like the Nelson equivalent, where it'll describe a couple different things. I have the bare minimum of a file here. We have several other fields you could put in here, but I needed to fit on a slide. So the manifest file has three main sections. The first one is the unit section, which describes what to deploy. And I say logical here because we haven't said anything like what we're actually deploying, right? There's no like Docker image or path to a jar that I'm actually pointing to. I'm just saying I'm going to deploy something called foo with these dependencies and these versions. The second section is a plan section, which describes the how to deploy it. This will include stuff like how much CPU to give it, how much memory to give it, how much disk space, how many instances, and stuff like that. We also have a blueprint here, which I'll talk about in a bit. You can think of this as essentially how you want to, at a very high level, how you want this, where you want this thing to be deployed. So in this case, it'll be, I want this to be deployed on a machine that has GPUs on it. And then finally, at the last section, we have namespaces, which is the actual where to deploy. You can think of these as Kubernetes namespaces, which is true for the Kubernetes backend of Nelson. I'll talk a little bit about that later. For Nomad, I believe these are more or less logical, maintained internally. And in this section is also where everything is tied together, where we're saying for the dev namespace, I'm going to deploy foo with this given plan. The second file that you're going to work with is called deployable file. And instead of being checked in, this is going to be attached at a per release or as of recently a per GitHub deployment basis. So this sort of ties together the logical definition of what to deploy with the physical. So here I'm saying I'm deploying the thing with logical name foo. This is going to be the version of myself. And this is the actual Docker container I want you to deploy that corresponds to it. So starting with those two files, users are going to then make a deployment. That should be capitalized, actually, because when we say make a deployment, I mean make a GitHub deployment, which is like a GitHub concept. Older versions use GitHub releases for the same reason. Nelson-enabled repos also have a webhook installed that correspond to whatever hook they're going to use. So in this case, we're going to assume that the repo has a deployment webhook. So a deployment is made. It can be done manually, and you can attach a deployable file yourself, or we provide a tool called Slipway that will gives an easy command line interface for you to do it. And so you could also do it in CI if you want to do continuous deployment, for instance. But once the deployment is made, the webhook is going to call Nelson. Nelson is going to, based on the contents in a webhook, go back to the repo and fetch the manifest and the deployable files, parse it, figure out what, where, how to deploy it. And then from there, it's going to deploy to a scheduler, execute deployment into its graph. And that's sort of job done from the user's perspective. From then on, the user is only going to interact with their workload using the Nelson command line interface, which I'll talk about in a bit, and using other tools like Kibana or Grafana to look at logs and metrics and stuff like that. It's assumed that whoever's operating your infrastructure has those tools set up for you. Other stuff Nelson is going to be doing in the background that's sort of separate from the deployment workflow is stuff like automatic traffic shifting, cleaning up deprecated workloads, and stuff like that. So I can show you a little bit about what the CLI provides. So sort of the most basic thing that you can do is to ask Nelson to essentially promote a certain workload from a dev environment to a production environment, for instance. By default, everything goes into whatever your administrator has configured to be the default namespace, which is often a dev environment. And then once you've determined that that workload looks good and you want to release it out into the world, you can tell Nelson to commit it into a QA environment or to a production environment. And Nelson will execute essentially the same workflow as it did for the default deployment, but for just in a different namespace this time. One of the subtle implications of this, of course, is that your workload is expected to just do the right thing just by moving from namespace to namespace. You can do some runtime inspection of this through environment variables that Nelson injects. So you can, but it's expected that, say, the way you pull secrets or the way you do config management can just happen transparently from namespace to namespace. Other things you can figure out what's currently deployed based on the namespace or the data center. There are other filters on this as well, such as give me only stacks that are failing or give me only stacks that are healthy. So this gives a high level. One of the more important things to note here is we have a GUID there. Given that GUID, you can also ask Nelson to what we call inspect. Essentially, that gives you diagnostic information on how Nelson itself interacted with your workload. So the status history and the logs here aren't logs for your application, they're logs with how Nelson interacted with it. So you can essentially see if Nelson successfully deployed a workload or if it failed to deploy for whatever reason. You can also see what time it was deployed, what plan, what namespace it was using. Yeah. Nelson also lets you do some basic runtime information. So this is the Nelson stacks runtime command. That will give you just health checks for your workload. Where those health checks come from, those can be written inside that initial Nelson manifest file. So you can use Nelson stacks runtime to get that kind of runtime information. But beyond this, the tool is intentionally not intended to give you like application logs through like how kube control logs might give you logs. That's all assume that you have that in Kibana or Splunk or something. So that's the main commands I personally use. There's a lot of other commands in the CLI. It's got a good help page. We have a website that I'll show later on. But that essentially ends the user's perspective of Nelson. And it was kind of brief, but that's also kind of the point of Nelson. One of the goals of Nelson is that service owners should just have to focus on their service and not worry about all the complexities associated with a scheduler like Kubernetes. So this is sort of benefits on both sides, right? We don't want service owners to think about schedulers or ops. We want them to just focus on the service, and everything else should be just deploy the thing and something will automate it. On the other side, operations doesn't want to be in the business of deploying other people's things. So that's why Nelson has a self-service deployment model. But at the same time, they don't want people to have, like, say, kube control access to the cluster, because that's a really powerful tool, and you don't want people messing with your cluster without you knowing, right? So it's sort of the reason we keep it limited is to benefit both sides. So now I can talk about Nelson from the operator's perspective. So this is what happens in the back end that hopefully your service owners don't have to know too much about. At least they shouldn't have to maintain. So in its full, Nelson is going to need a GitHub application, a system that can do dynamic credential provisioning. This typically means HashiCorp Vault. A system that can do service discovery and health checks, and then a scheduler. At a minimum, Nelson only really needs a GitHub application, a scheduler, and a service discovery system. And if you're using the Kubernetes backend of Nelson, you can sort of fold the service discovery and health check part into just Kubernetes itself. It's easy. In terms of implementation, I'll talk about it briefly. It's pretty easy to extend. Right now, in the newer version of Nelson, we're currently only supporting Kubernetes. In one iteration before, it was both Kubernetes, Nomad, and Mesos. It's pretty easy to extend as long as you support your scheduler or whatever supports pretty basic functionality. Essentially, can you launch a container, can you delete a container, and can you give me the health of a running container? So if you want to use this with like Yarn or like Netflix's Titus or something, it's pretty easy to extend. It's also built to work with multiple data centers. And if you really want to get wacky, if you have like multiple data centers, each which run their own scheduler, Nelson can deal with that just fine, right? You can have one data center that runs Mesos, one that runs Kubernetes, one that runs Yarn. You're good to go, as long as they can all deploy containers. And you have like more or less a cohesive way of like, if you're running like a Spark job, it better work in all the environments. But for like microservices, it'll work out of the box. In terms of deploying Nelson itself, Nelson can be deployed pretty much anywhere. You just need network line of sight with GitHub and the various systems you're interacting with, of course. If you're just doing like a single DC, you can even deploy Nelson inside Kubernetes itself, right? Nelson comes as a container, so you can deploy Nelson inside a Kubernetes cluster that it administers. That way you can get like lifecycle stuff and ingress stuff for free. But yeah, by default, Nelson comes with a container. If you can make it run somewhere, you're good to go. So I stopped the user's workflow by saying like Nelson's going to deploy it into the cloud, but the cloud's going to have to be something, right? It's just hopefully to the user, it's deploying it to the cloud. In the back end, something is actually happening. So I'll talk about the second half of that workflow. So we'll start by Nelson receiving and parsing the manifest for the repo that did the deployment. Nelson is then going to dynamically provision credentials if that functionality is enabled. It'll write service discovery information to a service discovery system, either making an entry in console or creating a Kubernetes service. That'll be tied to the specific name and version of whatever is being deployed. And then finally, it's going to actually deploy the thing to a scheduler. After these steps are done, Nelson is done with its job. And this is a very intentional thing that we're doing. Nelson isn't going to try to do anything fancy like dynamically render the credentials into the running container or automatically connect containers together. Nelson is just pushing that information somewhere, and it's up to people to pull that information. And this, in part, is because we don't want Nelson to be in a hot path. If Nelson goes down, everything should still continue to work. The only thing that should stop if Nelson goes down is just people can't deploy. So that's a very conscious decision that we made. Now, given these systems, and given these various backends, Nelson there's generally like one size fits all way for Nelson to interact with these systems, right? We listen to GitHub webhooks. There's really only one way to implement that. Given Nelson's model, there's sort of one straightforward way to push that information to Vault and push that information to console. But when it gets time to actually deploy it onto a scheduler somewhere, that's when things get tricky, right? Because different organizations are going to expect things to work in slightly different ways. Especially for Kubernetes, you can have stuff like different people can use different Kubernetes versions. People want to schedule their stuff on certain pods or on certain nodes. People want magical annotations. So like some places will require magical you just annotate your workload with specific labels, and then something is going to come and scrape metrics from it at a specific endpoint, right? So there's different organizations are going to do things slightly different. In a previous iteration of Nelson, the way it submitted jobs to the scheduler was in a very prescriptive way, right? We were saying we're going to expect that you're on Kubernetes version 1.8, which happens to have the schema. You're going to have the labels we tell you you're going to have, and you're not going to be able to define stuff like tolerations or node affinities or anything like that. So as Tim and I were trying to deploy this and work with it, we constantly were asking questions like, what if we want to schedule on a GPU node? What if we wanted persistent volumes? What if I only wanted to schedule on certain nodes? What if I needed certain annotations? What if Kubernetes one day decided that they were going to use YAML, they were going to use, I don't know, what's DAL or something? Then what, right? We would have to always be playing catch up. So our answer to this, and I think some people are going to cringe when they see the next slide, but our answer to this, which has worked out well, is our notion of blueprints, which is essentially a fancy way of saying we're going to have templated specs of whatever your scheduler wants. In the case of Kubernetes, this means templated YAML. I'm sorry. In the case of Nomad, this is going to be templated HCL, for instance. But essentially, we're now allowing, instead of having what is sent to the scheduler be inside Nelson's source code, whoever is operating and deploying Nelson will have a templated spec that will still be interpolated in a more or less deterministic way, right? We're not giving you free access to variables. You just say, this is where I'm going to put the stack, this is where I'm going to put the image, and stuff like that. But we allow the operators to control what blob is sent to the scheduler. And you can have multiple different blueprints, and you can have them under different versions, and users will then specify blueprints by name and version in their manifest. And so you can have one blueprint that says, this is for experiments, so I want to schedule that on a GPU-enabled node. And I have one blueprint that's for like sort of a vanilla service that has metrics on a prescriptive port or something like that, and they'll use that blueprint. And so this still allows users to have sort of a high-level way of controlling where things get deployed without having to do questionable things like allow them to splice in arbitrary YAML, which we entertain for about 10 seconds, or allow them to, or like just give them kube control and like hope for the best. And now on the flip side, for operators, it allows them to control a lot of the stuff specific to their organization, while again, not having to deal with, like, if you let people splice an arbitrary YAML, they're going to do some weird stuff with it. So we think blueprints solve a pretty, like it's a good middle ground between the different trade-offs. And it's been working out well for the past couple months we've been using it. So to give an overview of now the full Nelson workflow, end-to-end, assume we have the GitHub repo is Nelson enabled, which means we have a webhook installed. We've got the Nelson manifest file. We make a deployment. That deployment triggers a webhook, which calls Nelson. Nelson goes back and fetches the manifest, dynamically provisions credentials, writes service discovery information, deploys the thing, and then from there on, that's the end of the workflow end to end. In the background, the user is then going to use the Nelson CLI or other tools to interact with the deployment. And then in the background, Nelson is going to be doing its own sort of automation to make things nice, traffic shifting, health checks, cleanup, that stuff. So this is the roadmap. This is some of the bigger items that we're working on moving forward. So one thing is for the Kubernetes backend, we don't really have a one-size-fits-all answer for service to service, right? In terms of like, where do we publish this information that like service D 2.2 lives here and service D 2.3 lives there. The Kubernetes ecosystem is sort of still evolving. We could do this through services and having labels. That kind of has problems because you can mutate labels halfway through, and we don't want people to do that. We could do this through like an Envoy sidecar and publish it as a CRD. Istio is coming out. We could do it through Istio. So there's not really a clear answer of where people are going. So we don't have a one-size-fits-all answer. If you have opinions about this, we'd love to talk to you. But that's something that's on our roadmap. Another thing we want to do is currently Nelson only supports deployments off of like a single master branch. It's really useful to be able to, both for the monorepo use case and also just for like testing, for people to do deployments off of branches or pull requests. So imagine like if you make a small change to a service and you create a branch for it, and you tell Nelson to deploy that branch, it'll do the same workflow, but just deploy it somewhere else that doesn't affect the dev namespace, for instance. And then you can send the business guys or whatever a link to your fork of the service, and they can play around with it, and once everything looks good, once the branch closes, Nelson can then detect that with like a webhook or something and automatically shut it down, similar to how it does lifecycle management in general. So that's, Tim and I have been talking about that. I'm not done. We're also, in terms of internal stuff, right now, Nelson does like JSON over the wire. We're moving that to protocol buffers and gRPC if people want to build other tooling in other languages, and so they don't have to write their own JSON parser, and to actually just formalize that we have an API. Nelson currently doesn't have a good, like a web UI, and so we're working on that as well. And then right now it's kind of a hassle to get started with Nelson because you need to have GitHub, you need to have a Kubernetes cluster running at the minimum. We're trying to, if you're playing around with Nelson and you're having trouble, you know certain pain points, or you have ideas on how we can have a smoother demo experience, please talk to us, and we'd love to get your help on that. We do have a website. For those who visited the Nelson website in the past, you will notice it's different. About 2 months ago, having known Tim for like 2 years, I realized that he knows how to do front-end stuff. So we have a hip new cloud-native slick website now. So you can visit with a slick new .io domain. We were going to be getNelson.cloud, but decided that was a bit much. So we'll just stop at .io. Features not covered today that are either covered in either Tim or mine's past talks, or that are just on a website. Automatic traffic shifting, how Nelson handles like load balancers and ingress, how graph pruning works. We have audit logging in Nelson, so you can sort of see if people are like wondering like why did my workload like automatically get deleted. That's in the audit logs. There's stuff like Slack and email notification whenever things get deployed or cleaned up. And we're stuff like deployment off branches, PRs, etc. Other than that, we have slick website. We have a repo that contains everything that Nelson uses, including Slipway and other tooling. We have a Gitter channel that we monitor. I do have Nelson stickers, which they're here. I have Nelson stickers if anyone's interested. And if you have questions, I think I have like 5 minutes to take questions. And if otherwise, Tim and I are around today and tomorrow, so feel free to approach us. Thank you. This is bad because the person who's about to ask a question is on my team.
Yeah. So with your description of the persistent deployment model, could you get in a situation where you have a service that depends on like A version 2.2, but transitively depends on A 2.1, and would that cause problems?
So like, can we get into a situation where services either knowingly or unknowingly lie about what their dependencies are?
No, what I'm saying is like you depend on A 2.2 directly, then you depend on C, which depends on A 2.1.
Probably, you can't do that?
No, we have a cycle to detect that.
Oh.
That's what you're talking
Let me,
about.
no, it's not a cycle. It's like you have some third package. And the reason I bring this up is because it's the problem of package management. So like you have your service, you directly depend on A 2.2. Then you have some other package C, which also depends on A, but it depends on like A 2.1.
That's okay, because
That's okay.
It's semantic versioning, so you would be able to bump the operators.
And also because Nelson doesn't account for transitive dependencies, right? Like it doesn't matter to us that C is incidentally using an older version of A, as long as you can get into issues if like C has semantics that depend on A, and you're seeing like one semantically incompatible version of A, and C is using a different one. So that's possible,
Okay.
but there's nothing. It's possible, yeah.
All right.
But like Tim said, if it's actually forming a cycle for whatever reason, then Nelson will detect that and
stop you. Okay. Coming back to your earlier slides about the potential that different services rely on different versions of other services. Do users generally run to the stage where they say own service A, and because of the way other people are dependent on you, now you've got about 5 to 10 versions of your service running in various states and possibly interacting with your database and everything like that. Like, do they have control?
So we don't provide a way to sort of force people who are existing dependents off of you, but you can deprecate a workload in Nelson, which essentially means any additional deployments after this will fail if they depend on this old version, right? So if I have A version 1 and A version 2, and I deprecate version 1, and someone tries to deploy a new thing after I deprecate it that depends on version 1, the deployment Nelson will actually stop that. So you're trying to depend on a deprecated version of A. Stop that.
Okay, so as long as the other services are fairly regularly deploying, like
Yeah. The only case where you have like multiple versions is if like one team is depending on you and never deploys ever again. In which case you can probably walk over there and yell at them for a variety of reasons. Why aren't you deploying?
Does the service, does Nelson support deployment pipelines?
Are you talking about stuff like workflows where like run this job and then if that job completes, run this job?
Yeah, so basically we have the same instances of the application on services and different AWS regions, for example. And we want staggered deployments.
Oh, for staggering deployments, not for creating like a DAG app deployment, but just like deploy in like the West region first, and if that looks good, then deploy in the East region. I don't think we have that right now. That's an interesting use case. Maybe talk to us afterwards, because we don't have an answer to that right now. But that's definitely interesting.
Cool. And the second question was, how do you, what's the support for like building automated workflows and auto rollback? So, are there plugins that users have to write?
So right now, Nelson is fairly prescriptive about that. So there is support for, in terms of automated deployments, since everything is just based off of a GitHub deployment. If your CI is doing like GitHub deployments off every commit to master, then you basically have continuous deployment. So I briefly mentioned automatic traffic shifting. I can talk about it really quick. So Nelson is keyed off semantic versions, right? So there's major, minor, patch. If you're deploying, the only time when Nelson is going to force someone to explicitly depend on a new version is if it's only keyed off the major and the minor version. So if you're dependent on 2.1 and someone deploys 2.2, you have to make an explicit choice to say, I want 2.2 now. But if you depend on 2.1.0 and I deploy if you depend on my service 2.1.0 and I deploy 2.1.1, then Nelson is going to automatically traffic shift based on some pattern. And if things begin looking unhealthy, if your health check can detect that your thing or my thing looks unhealthy, it'll reverse the traffic shift.
And I can provide the metrics for the health of it.
Yeah.
I can provide now.
That'll be in a Nelson manifest file, I believe.
Thank you.
2 more questions.
You mentioned it before, but I do have a question if it can handle DAGs, short-term jobs.
So this has come up a lot because DAGs are very common, as it turns out. Nelson purposely makes a decision not to support DAGs as part of the principle that we want to deploy the thing and to not be in your way. So our answer to if you want to deploy like one job and then once the job completes, run like these 2 jobs or something like that, is to just, as part of your container's entry point, delegate to something that does handle that. So like for instance, if you want to run a Spark job as a container, we're not going to have like Nelson spin up, like run this job and then run this stage and run this stage. You're just going to instantly have a container that on entry point is going to run Spark submit or something like that. So essentially, we're delegating to a separate system, and that keeps Nelson out of the hot path.
Anyone else?
Thank you very much.